Welcome to solverfy.
So we have a square sheet. I'm bad at drawing, sorry about that. Of side. There is charge on it of 275 nanocoulombs, and the square sheet has a side of 25 centimeters. We want to find out for part A the field at the distance of 1 centimeter above the surface. Of course, this is not for scale. The 1 centimeter would have been very small. Now, because this distance is very small, we can consider this sheet to be an infinite sheet. And we've already found the formula for the field near an infinite sheet. We saw that it was sigma by 2 epsilon naught, where sigma is the charge density. That is it. As soon as you recognize that this is the situation, the problem is trivial. Sigma is obviously Q, the charge by area. Charge is 275 nanocoulombs, so that's 275 into 10 power minus 9 coulombs, divided by area is obviously the square of the side. 25 centimeters is 0.25 meters, and that's square. Now divided by 2 times epsilon naught is, as we know, 8.85 into 10 power minus 11 coulomb square per Newton meter square. Now you can see that the units give you Newton per coulomb, which is what you would expect for electric field. And the number turns out to be 2.5 into 10 power 5 Newton per coulomb. Of course, this is only the magnitude field. It's important to find the direction too, because we consider it to be an infinite charged metal sheet. The infinite charged sheet, the electric field would be perpendicular to the surface itself, which means it would be something like that. For part B, we consider the field at a distance of 15 meters. Now, notice that if this was really 15 meters, the sheet would look something like this in that green color over here, which means that is 15 meters to 25 is 60 times larger than 25 centimeters, and hence we can think of it as a point charge. So for a point charge, the electric field would simply be 1 by 4 pi epsilon naught q by r squared. So we know that 1 by 4 pi epsilon naught is 8.988 into 10 power 9 Newton meter square per coulomb square, times q is 275 into 10 power minus 9 by r squared is 15 squared, because 15 meters. This gives us 11 Newton per coulomb. Again, the direction of the field would simply be away from the sheet.